In this lecture, we'll be covering section 2.5 on measures of the center of data, and I have to admit that I'm a little more excited about this lecture than I have been any of the previous ones because we're actually going to do some math in this section. Again, the topic is measures of the center of data, which is basically just a nerdy way of saying average. Let's look at the definition. A measure of center is a summarization of a collection of data which is designed to describe an average or typical value in the data set. When we talk about measures of center, we're really just talking about averages. We're going to go with this nerdier expression, measure of center, instead of just saying average, because the word average is loaded. When you use the word average in an everyday conversation, most people get a specific average in mind, the one where you add them all up and divide by how many there are. To avoid that confusion, we're going to use this phrase measure of center to describe all averages, and then use the formal terms for each of the measures of center to distinguish between them. But what we're talking about here are really averages. We're trying to describe the center of a set, or what's typical in a set. There's a good chance you'll be familiar with the three measures of center that we're going to describe here. The first is the mean. And this is the one that most people think of when you say the average. Like when I give you guys an average grade in class, I'm reporting the mean. The mean of a collection of data is the quotient of the sum of the pieces of data and the number of pieces of data. I know that's not the easiest way to describe a mean, right? You would just say you add them all up and divide by how many there are. But this formal definition gives us an order of operations. We find the sum of the pieces of data, we find the number of pieces of data, and then we find the quotient of those two numbers. So there's no confusion about the order of operations when you write it in this technical way. But the easy way to describe it is that you just add up all of the values in the set and you divide by the number of values in the set, and that's what we call the mean. Here's a simple example with sample data. We've got these five numbers 22, 16, 41, 25, and 33. I didn't provide any context here. We're just going to find the mean. To find the mean, we find the sum of the values in the set. So I'm going to add these five values together. And then I'm going to divide that sum by 5. It's the quotient of the sum of the values in the set and the number of values in the set. So we'll find this sum. So let's see here, 22 and 33, that's 55. 55 and 25, that's 80. These add to 57, and 80 plus 57 is 137. We're going to divide that by 5. 5 goes into 13 two times, with a remainder of 3. 5 goes into 37 7 times with a remainder of 2. So that's 27.4. That result of 27.4 is supposed to be an average value in the set. It should describe the center of the set. And if we took the time to order this data from smallest to largest, 16, 22, 25, 33, 41, you can see that 27.4 does in fact fall near the middle of the set. That's what it's designed to do. It's designed to describe what's in the center. Sometimes means don't do a good job of describing the center, and that's why we have other measures of center. The thing that we like about the mean is that it's very arithmetic and it takes all of the data into account. Because it's got all this arithmetic in it, it makes it easier to prove theorems that you can't really do with non-arithmetic measures. That's what we like about the mean. But there are times where the mean does a poor job of describing the center, so we're going to look at other measures of center as well. Because means get used so much, we use notation to describe them. And depending on whether the data comes from a sample or a population, we use a different symbol to represent the mean. The mean of a sample, or sample mean, is denoted by this x with a little bar over it, and we read that as x bar. So in that previous example where I made sure to specify that this was sample data, I could end by saying that x bar equals 27.4 because this is the mean of a sample. We use x bar to represent a sample mean. For parameters, values that come from the entire population, it's common to use Greek letters for the representations, and you see that here. The mean of a population, or population mean, is denoted by the Greek letter mu. I know it kind of looks like a U with a tail on the end, but it's actually the equivalent of M in the English alphabet. So the way you spell mu is mu. So we pronounce this phonetically the way that a kitten cries, mew. So it's not a cow, moo, it's a kitty, mew. Mu is the symbol for the population mean. Now, it would be inappropriate in the previous example to use the symbol mu because this wasn't population data. It specified that it was sample data. While we're talking notation, let me just point out a couple more bits of notation, and then I'll turn that definition of a mean into a formula. The number of individuals in a sample, which is what we call the sample size, is denoted by lowercase n. Lowercase n is used to represent the size of a sample. So in that previous example, the sample size n is 5. The number of individuals in a population size, is denoted by capital N or by the Greek letter nu. We're not going to specify which one we're using because it's going to be so rare that we need this symbol. We'll only see it in a couple of formulas, and they aren't things that I'm going to ask you to do by hand. With one more bit of notation, I can get to those formulas I was talking about. We use the uppercase Greek letter sigma in order to represent summation notation. So when you see this Greek letter followed by something like an X, that basically means add up all of the X's. So if X is the variable in a statistical problem, it says add all of those up. The formal way to read this would be the sum of all X, but basically it's just telling you to add up all of the X's. Using all of this notation, we can write our definition of a mean in two different ways. If we're talking about sample data, then the sample mean is the sum of the values of the variable. The variable is called X here, the mean is called X bar. And we divide that by the sample size, which is n. This formula says in order to find the sample mean, you find the quotient of the sum of the values of the variable, the pieces of data, and the number of pieces of data, which would be called lowercase n here because this is a sample mean. That's that definition, but in symbols instead of in words. We can do the same thing for the population. Mu is equal to the sum of the values of the variable. Now, with this notation, it's not clear what the variable is called, but we're just going to keep calling it X, divided by the population size. Again, this formula in symbols says the same thing that this definition says in words, except it's specific to populations. Now, I'm not saying that you need to memorize these formulas. They are nice when you need to do some kind of algebraic manipulation, but that's not the kind of stuff we're going to get into in our class. Because you already know this definition in your own terms. You don't need me to describe all this. You know how to find a mean. But formulas like these are nice, concise ways to represent definitions, and you'll see that more and more as the class goes on. It also gives you exposure to these symbols that we're going to be seeing quite often throughout the course. Let's do that same example, but demonstrate with the calculator how to find it. So here's that sample data again. I'm going to bring up my emulator here. You'll notice that I edited this out, but I double-checked my arithmetic to make sure that I didn't make a silly mistake. This is one way to find the mean in the calculator, but it wouldn't be the most efficient way to do it if we had like 30 or 40 pieces of data. It also isn't going to be best when you've got more than one thing you want to do with the data. Besides just find the mean, maybe you want some other measures. The first thing I need to do is input the data into a list in the calculator. And the way you access your lists is to press your stat key. Stat is 2 to the right of your green alpha key. You'll see the key press history come up down here. You'll get this screen that says Edit Calc Tests across the top. And what we want to do is edit our list, which is choice 1. You'll notice that there's already a cursor that colors in number 1, so you could use the Enter key, but I'm a numbers guy, so I'm going to press number 1 to select that. I already have a blank list here. If your list is not blank, the way that you clear out a list is to use these arrows to scroll up to the list name, then push the clear key and the down arrow, and that will clear your list. I'll demonstrate that again after we put in our numbers. So our data was 22, so I typed 22, and then I hit the Enter key. 16, enter. 41, enter. 25, enter. 33, enter. You'll notice that it's prompting me for a 6th value in list 1, which means that I have 5 so far. You want to make sure that you've typed in all of the data. You can double check to make sure that these are all typed in correctly. Like I'm going to look back at my list. 22, 16, 41, 25, 33. That looks right. If I had one wrong, I would just scroll up to the one that was incorrect and change it. So like if the 41 was supposed to be a 19, I would type 19 and hit enter. But that's not what I want, so let me scroll and change it back. 41, enter. So to make edits inside the list, if you mistype something, you just overstrike it and then hit enter. With my data in list 1, I'm going to quit back to the main screen using second and the mode key. And now I'm going to ask the calculator to do a command that will find the mean. If you're already familiar with this calculator and its statistical package, you might know that there are multiple ways to find means. I'm going to demonstrate both, but in this section I'm going to keep it simple by just finding the mean rather than getting a big output display full of things that we don't know yet. So I push second and the stat key. You'll notice that the headings are different. I get names, ops, math. I want to scroll to the math option, and here's where you'll find out how lazy I am. I could scroll twice to the right, but I'm going to save a 10,000th of a calorie and just scroll once to the left. And you get all of these different mathematical options. Choice 3 is the mean. And again, I'm super lazy. I guess I could push the down arrow twice and then hit enter. But why do that when I can just push the 3 key? Now we get a prompt on our main screen. It wants to know the mean of what? Well, I want the mean of list 1. And if you look carefully above the 1, 2, 3, 4, 5, and 6 keys, you'll see L1 through L6 respectively. They're in the same color as my second key, so I'm going to push second and the number of the list. You're supposed to close the parentheses, and if it bothers you not to do so, you can use this right paren above the 9. But this isn't like a computer program that has to compile, so you can just hit enter. And there's that 27.4. You might argue that that took a really long time when we could have just added it up by hand and divided by 5. And you're right, for a really small list, it might be just as fast to do it by hand as it would be to use the calculator. But again, you're going to be dealing with larger data sets in the future, and you're also going to have data sets where I don't just ask for a mean, but I also ask for other measures, and it'll be more efficient to just use your calculator to knock all those things out. Just to finish this off again, we'll write X bar because this is sample data, so I want to use the symbol for the sample mean, equals 27.4. Of course, that's the same thing we got before. Let's do another example with the calculator. Here I put a little bit of context to it. These are exam scores for an entire class, and I made the class small, but because it's an entire class, we're actually talking about population data here, and that's why I emphasized that it's for the entire class. And you see the scores, and one of them might stand out to you, right? You see all these scores in the high 70s and the 90s, and then there's this student that got a 2. Now, I don't point that person out to mock, but I do want to point out that that number is way different than the rest of the data, and I'm going to use that to illustrate a point about means. First, let's just go through the mechanics of finding this mean in the calculator. You could find it by hand. It wouldn't be really hard to add these numbers together. But adding together a bunch of 2-digit numbers and that poor, unfortunate single-digit number will take a little bit of time. It'd probably be faster to do this by using the lists in the calculator. Let me bring up my calculator. I'm going to clear out this main screen. Anytime you want your main screen to be blank, you can just push the clear key while you're on it. Unless you've already started typing something, in which case you'll have to hit it twice. The clear key will just give you a nice blank home screen. I need to change my list to the new list, so I press Stat, Choice 1 to edit my lists. And now let me again demonstrate how you clear a list. I'm going to use my up arrow to scroll up to the list name. Then I push the clear key, and you'll notice nothing happens to the list at first. You have to hit the down arrow, or I think the enter key will work too, and that will clear your list. Make sure you don't use delete on your list because that will delete the whole list. Let me show you. If I scroll up to list name and hit delete, the whole list is gone. L1 has disappeared. And you can get it back by inserting list 1 But rather than doing that, you should just clear your lists. Don't delete your lists. Let me go through and type in these test scores. So there was an 86, a 91, 93, 85, 79, 94, then the 2, a 98, an 89, and an 88. I can see that it's prompting me for an 11th number, which means that I've typed in 10 so far. I may have gone through this kind of fast in my first example, so let me slow down here and show you. I want to go from this screen back to the main screen. If I don't go back to the main screen, then it's going to insert my answer into the row, which isn't a big deal here because we're only finding the mean. But if we had an example where we were doing multiple measures and we weren't doing them all at once, we don't want to change the list when we go from measure to measure. So to quit back to the main screen, you'll notice above the mode key it says quit. So it's second and the mode key to get back to your main screen. To find the mean and only the mean, I hit second and then stat. That takes me to the list options. I want to do some math with my list, so I scroll over to the math option. The mean is choice 3. I'm finding the mean of list 1, so second and the 1 key. And this time I'll close the parentheses even though it doesn't matter because it does bother me not to close them. I didn't close them in that first example just to prove a point, but I have to admit that I was getting the shakes when I didn't close it. Enter to find the mean, and we get a mean of 80.5. The population mean is 80.5. That sounds like a good class average, and you might not think twice about it, but let's go back and look at the data again. 80.5 is actually smaller than almost every piece of data in the set. Right, there's this student that scored a 79. This is barely above that. There's the 2, and everybody else scored above an 80.5. 80.5 actually isn't in the middle at all. It's on the low side. The mean does not do a good job of describing the center of this set. And why is that? Well, it's because there was this one value, the 2, that's severely affecting the calculation of the mean. If that 2 wasn't in there, the class average would be much higher. That one score is dragging the class average down. In fact, I feel tempted to play. Let me show you. If I go back to my list and I take out the 2, I can do that by hitting delete. It will just delete that entry. And then I go back and calculate the mean again, but without the 2 in there. We get a mean that's almost 9 points higher than we had before. That one person dragged down the class mean by over 8 points. Because a single drastic value, which we often call an outlier, can easily sway the value of the mean so that it doesn't really reflect the center of the set, we have other measures of center. The mean is certainly the most common one, and it will be the one that we focus on the most in our class because it's calculated using arithmetic, and it's got all these nice properties that we can use. We still want to talk about these other measures of center because sometimes the mean doesn't do a good job. Furthermore, I just simply want to make you aware that there are many measures of center, and when somebody reports an average to you, you should be aware that they're not necessarily telling you the mean. They could be using one of these other measures. That's something you'd want to think about. The next most commonly used measure of center is the median. The median of a collection of data is a number which splits the data into 2 equally sized pieces when the data is sorted. So the median says, okay, I'm just going to find a number that divides the data into 2 equal pieces. There'll be just as many numbers to the left of it as there are to the right of it if we were to sort the data, either from smallest to largest or largest to smallest. Because we're talking about the middle of the set, it doesn't matter which way we sort the data. You'll notice that I have a tendency to sort things from smallest to largest. But you could sort the data in either way. The median will fall in the middle and will be the exact same result. Let's look at the exam question again. But now we're going to find the median score. So to find the median, I need the data sorted. And so I'm going to sort this by hand, but as you might guess, we could sort this with the calculator. And also it may have caught your eye that the calculator will actually just find the median. But let's do it once by hand. So 2 is the smallest value, obviously. And then there's a 79, and an 85, and an 86, and an 88, and an 89, 91, 93, 94, 98. So there's the sorted list. And now we want to find the number in the middle, a number that splits the data into two equally sized pieces. And when you look at the data, you'll notice that you can't pick one of the numbers that actually falls in the set. Like if you pick 88, there are 4 numbers that fall to the left of that, but 5 to the right. And if you pick 89, you have the opposite problem. There are more to the left than there are to the right. So when you have an even number of values like this, there are 10 values in this set, we actually identify the 2 middle values and find the mean of those. So I do 88 plus 89 divided by 2, which is 88.5. And that does a pretty good job of describing the center because it is in the middle of the list. There's no denying that this is a measure of center because it's the center of the list. It divides the data into 2 equal pieces. One of the issues with the median is that it's just a location. And that location doesn't depend on any of the other values in the set. It only depends on those 2 in the center. That sounds like a good thing, and it is in this example because it ignores the 2. I would argue that the median does a much better job of describing an average for this set than the mean does. Let me demonstrate how to find the median using the calculator. One thing I'm going to have to do is put that 2 back into the list. This will give me a reason to show you how to edit a list after you've already typed it in there. Let me clear out the key press history. So stat, choice 1 to edit my list. And because it doesn't really matter where I put it, I can just enter it at the bottom of the list. That wouldn't be a big deal. But if you want to put it in a specific spot, I go to the spot where the piece of data should be, I push second and the delete key, and that will open up a space and it will put a 0 there just by default. And then you overstrike it to the value that you want it to have. I wanted it to be a 2. And now the list is restored to the way it was before. I do not have to sort the data for the calculator. It'll do that somewhere else in the calculator, find the median, while leaving the list in its original format. I'm going to quit back to the main screen so that I don't insert the median into the list, second in the mode key. Let me clear this out. I push second, stat, scroll to math, just like you do for the mean, and the median is choice 4. So rather than scrolling, I'm just going to push the 4 key. I want to find the median of list 1, so that's second and the 1 key. Close the parentheses because I have a problem. Hit enter, and there's that 88.5 that we found when we did it by hand. You'll notice that I didn't mention a symbol for the median. There actually is a symbol for the median, but we won't need it because we won't be working with medians very often. We'll be working with means on a much more regular basis because of the arithmetic properties. So we'll just write median equals 88.5. Since I mentioned that you can use the calculator to sort the data, I'm going to demonstrate that here, but I hope this example just showed that for medians you don't need to do that. But because I mentioned it and because we're going to need sorted data for a future example anyway, let me demonstrate how to do this. If you press the stat key where we go to look at our lists and to edit our lists, you'll notice directly underneath it there are 2 options that say sort. Sort A, that stands for sort ascending, and sort D, which stands for sort descending. Because I sorted my data in ascending order, I'm going to do the same thing again. I push the 2 key, and it gives me a sort A prompt. It wants to know which list I want to sort. Close the parentheses, and I hit enter, and you don't see the list here. You actually can put the lists up on your main screen, but with longer lists, that's not a very effective way to do things. So we're going to go back to the lists and look at it. Stat, choice 1 to edit, and you'll notice now the list is sorted from smallest to largest. We didn't need to do that for the examples in this section, but you will need to sort lists for a future measure, and maybe you'll want to use the calculator to do that. You could also sort it by hand. I'm not going to give you any examples with hundreds of pieces of data. The biggest one I can imagine giving you would have 20, which wouldn't take you too long to sort by hand, but I still think it'll be more effective to learn how to do it with the calculator, especially because you're going to be doing multiple things to that list, not just finding a single measure at a time. Going back to how we did this one by hand, we had to find 2 central values and find their mean. That was because this had an even number of values. If the population size or if the sample size is odd, then you just find the number in the middle. So let's go back to our first example and find the median here. And this one's small enough that we can do it by hand, so I'll do that really quickly, and then I'll demonstrate it with the calculator as well. Sorting this from smallest to largest, we have 16, 22, 25, 33, 41. Again, an odd number of values. The sample size is 5. Because they're an odd number of values, there's some number that splits the data into two equal pieces, and it's this 25 right here. There are two numbers to the left of it, there are two numbers to the right of it. In general, the spot you want to go to is just the sample size plus 1 divided by 2. That's the location. So in this example, that's 5 plus 1 divided by 2, which is 6 divided by 2, which is 3. So we go to the third location of the sorted list, and that's where the median is. There is a rule for finding the center. Don't really need it here because you can see it visually. But if you had a list with 81 pieces of data, it would be hard to just pick out which one's in the middle. So this formula over here gives you a way to find the location of the median. Of course, we don't need any of that because we could just do this with the calculator. I encourage you to pause the video and try to do it on your own. See if you can enter the data on your own, get to the median on your own, find the median. I guess you know whether or not you got it right, but let me just demonstrate it really quickly. I'm going to clear out this old list by scrolling to the top, pushing clear and the down arrow. I'm going to enter the new list, and I'm going to put it in its original order: 22, 16, 41, 25, 33. I quit back to the main screen with second and the mode key. I press second and the stat key to bring up all the options for lists. I want to do math with my list, so I scroll to the math option using the left arrow. Choice 4 to find the median. Second and the 1 key to say that I want to use L1. Close the parentheses because I took too many programming classes. And then hit enter. And there's the 25 that we got by hand. Again, it was probably faster to do this one by hand because it was so easy to sort the data and it was easy to find the center. But it's good practice. So we have this choice between the mean and the median. Sometimes they both do a good job of finding the center, and in those cases we often prefer the mean because it's so arithmetic. Sometimes the mean has been affected by an outlier, so instead we want to use the median to describe the center. But sometimes neither of these two options can be employed, and so we have this third option that I'm going to bring up, which we call the mode. The mode of a collection of data is the value of the variable with the largest frequency in the data set. Recall that we define the frequency of a value of the variable to be the number of times that it occurs in the data set. So the mode is just the value of the variable that occurs most often. It occurs most frequently. Now I said we might want to use the mode in a case where we can't find the mean or the median. When would you not be able to find the mean or the median? Well, when the data isn't quantitative. If you have a set of categorical data, then you can't find the mean. In this example, I've got some responses to a multiple choice question. Maybe there was a survey with multiple choice questions on it. We're keeping track of how many times each answer was selected. If I ask you to find the mean of the choices, well, you can't do that. These aren't numbers. And if I ask you to find the median, you might argue that you could put them in alphabetical order and then find the symbol in the center. But that's not the kind of order that we mean. When we're finding a median, we're putting data in numerical order. Remember that if there are an even number of values in your set, the median is the mean of the two values in the center. So if it's not quantitative, you can't do that. But we can find the mode. The mode is just the value of the variable that occurs most often. If you scan this really quickly, you'll notice that there are 1, 2, 3, 4, 5, 6, 7 C's, which is way more than anything else. I think there are 3 A's and a couple of B's and this 1 D. But there are 7 C's, so the mode is C. So this is the main reason why I wanted to bring up the mode, because it's a measure of center that can be applied to categorical data. In fact, it's the only one we're going to talk about that can be applied to categorical data. Of course, you can use the mode on quantitative data too, but let me show you an example where the mode does a poor job of describing the center. Here I have a list of exam scores, And I've sorted these from smallest to largest to make it easier to scan. If you scan that really quickly, you'll notice that only one value gets repeated, and it's the 99. Right? The mode is 99. However, you'll notice every other score in this class is in the 50s or lower. So if the instructor came rocking in and said, hey, guess what? The average score was 99. People would probably start looking around and being like, what? My score was. And if the students started comparing scores, they'd be like, there's no way the average was 99. Well, that's because they're thinking of average as being the mean or something in the center. The mode is just the value of the variable that occurs most often. And it might not fall in the center. Here it falls on the very right. Furthermore, it's misleading because the 99 only occurs twice. It doesn't occur very much more frequently than any other value in the set. This is one reason why we don't want to use the mode if we don't have to. It's not that the mode can't be useful, but it's very misleading to say that it does a good job of describing the center in a general situation. Oh, and we have this other drawback to the mode. Sometimes a set of data has no mode. If there's no repetition in the set, then we say there's no mode. So if you have a set of numbers and they don't repeat, then you can't find a mode. If there's no repetition, there's no mode. The alternative would be to say that they're all modes, and that would be silly. So we say that there's no mode. So the mode has these two major drawbacks, that it doesn't really have to fall in the center, and that you can have a set of data with no mode. Because of that, we don't use it very often on quantitative data, unless you simply want to describe the most common value of the variable. Sometimes the mode is very useful. If you owned a skating rink and you wanted to have the skates to rent out to your customers, you'd probably want to know the modal shoe size because you'll want to have more skates of that size than anything else. The mode has value. It's not that it's completely useless for quantitative data, but if you're using it to describe the center of a set, it doesn't always do a good job. I also want you to take from this section the general idea that not all averages are means. When you hear an average reported, that might not be the mean. You might be given the median, the mode, or some other measure of center that we haven't discussed. There are other measures of center like the mid-range and the mid-quartile that could also be called averages. So not every average is a mean. Furthermore, when you're summarizing data, the mean might not be the best choice to summarize your data set. You might want to use the median, or because you've got categorical data, you might be forced to use the mode. So not all averages are means, and the average, which is best suited to summarize data, might not be the mean. So be sure to study measures of center. Remember that measures of center are supposed to describe what is average or typical in a data set. Let me know if you have any questions.